All right, Unit 10, Part 1. Today we start on predicate logic, also known as quantifier logic. So today we start on a whole new system of logic. You've just finished the second exam on Units 7 to 9 on proofs for sentential logic, and we've been doing a certain system of logic, sentential logic, for the first 9 units, and now we have finished that, and we start on a whole new system of logic, predicate logic. Okay, so first of all, why do we need another system of logic? Why do we need to have a different system, a different analysis of parts, just as we'll see, what we have in predicate logic? Well, because there are certain arguments which you can most clearly, intuitively recognize as valid, where we cannot grasp the validity of these arguments with the resources, with the formal resources of sentential logic. Okay, so the chapter, Virginia Klenk's chapter 10, opens her introduction of predicate logic on page 201, starting chapter 10, with 2 examples of arguments that are valid, but whose validity cannot be captured or expressed in the resources of sentential logic. All right, so one of them is, so from page 201, all rhododendron leaves are poisonous. This is a rhododendron leaf, therefore this leaf is poisonous. Okay, the other one is, all cats are mammals. This is a cat, therefore this is a mammal. All right, I've got my own example on the board, which I'll see in a minute. But the important, very crucial point, which you should have a handle on, which will motivate why we're doing this other thing, this other logic. And this is a point which goes for, there are many systems of logic, and it goes for why we bother with more and more systems. It's just, I want you to recognize that if we stuck with the resources of sentential logic, there would be many arguments whose validity you are absolutely assured of, right? You hear the 3 statements, can be more, but the 3 statements, the 2 premises and the conclusion, and you know with absolute certainty that the conclusion follows of necessity of the premises, right? You know that it is the case, you know this is a valid argument, which means you know that it is the case that if the premises are true, it's absolutely necessary that the conclusion is also true, right? So that's true of those 2 arguments you said. Here's another one, another simple example. So it's going to be this one on the right, right? All Australians are surfers. Dan is a surfer. All Australians are surfers. Second premise, Dan is Australian, therefore Dan is a surfer. So I want you to reflect, recognize, you know with certainty that that's a valid argument, right? There's no way, it is not possible for those premises to be true and the conclusion not to be true. It's not possible, right? We do have the link of necessity between premises and conclusion, which marks a valid argument. But given the mode of analysis we have been doing in sentential logic, we cannot formally express or capture that validity in sentential logic. Okay, so here we compare, right? Compare this argument, right? If Dan is Australian, then Dan is a surfer. Second premise, Dan is Australian. Conclusion, Dan is a surfer. How do we symbolize this in sentential logic? This one we can do, okay. Simple sentences of the first premise, Dan is Australian, Dan is a surfer. They are combined through the sentential operator of if blank, then blank, right? So it's if Dan is Australian, then Dan is a surfer. The second premise, Dan is Australian, therefore Dan is a surfer, right? That is the symbolic expression of this argument in sentential logic, the logic we are familiar with and that we have available, right? Notice that this symbolization does formally capture, does formally express the validity of the argument, right? Because why? As you'll all be able to say, I hope, this is quite clearly a substitution instance of the logically valid argument form called modus ponens, right? This is clearly as simple as it gets. Sentential variables just for statement constants, right? This argument is a substitution instance of if P then Q, P, if P then Q, and also P, therefore Q, right? Okay, so that's how we know we've formally expressed, formally grasped the validity of that argument. But here's an argument, the validity of which is just as certain, right? Your mind is just as clear that this is a valid argument, right? All Australians are surfers. Dan is Australian, therefore Dan is a surfer. Let's try and symbolize this using the resources of sentential logic. Well, in sentential logic, we treat simple sentences as wholes. That's going to be the thing that changes in predicate logic. In predicate or quantifier logic, those are synonyms. We're going to enter into the analysis of the simple sentences, separate them into subjects and predicates. But what I'm doing is motivating why we need to do this. So in sentential logic, we treat all simple sentences as wholes. That's why they just go, Dan is Australian, simple sentence gets just a capital letter. It's like an atom, so that's our basic atom or basic element of analysis in sentential logic. S, Dan is a surfer. Here, and of course also in sentential logic, when we have a officially compound or complex sentence where the sentential operator, right, if a sentence is compound or complex, it means a simple sentence is combined with a sentential operator to make another sentence. But we distinguished truth functional from non-truth functional sentential operators. Excuse me, from blank and blank, that's a truth functional sentential operator, and all the truth functional sentential operators, we do represent their structure. Blank and blank becomes P dot Q. But remember, all the non-truth functional sentential operators we treat, we just ignore because they're no truth functional. So a sentence which is officially compound or complex is treated as a simple sentence in sentential logic, so long as the sentential operator constructing the sentence is a non-truth functional sentential operator. So, right, a sentence like, Dan is a surfer because Dan is Australian. That's officially compound. You've got simple sentences, Dan is a surfer and Dan is Australian, right? Sentential operator blank because blank. But because the sentential operator because blank is a non-truth functional sentential operator, it is not the case that the truth value of that sentence is determined merely by the truth value of the component sentences. So because is a non-truth functional sentential operator, we ignore that structure, we ignore that complexity, and treat that whole sentence as a simple sentence. Right? So if you're asked to translate in sentential logic, Dan is a surfer because Dan is Australian, you just give it a simple capital letter, D, A, S. Doesn't matter which letter, but just gets one simple letter. Okay, so apply that now to our attempt to our symbolization of this argument in sentential logic. Point is to show you that we do not capture or express or grasp, cognize the validity of this argument, which is clear to us, right? We all see, it's obvious this is a valid argument. Same with those two arguments about the rhododendron leaves and the mammals and the cats on page 201 that Klenk opens the chapter with. There is no question, it's clear to us that they are valid arguments. So that's why we need more resources, that's why we need a new logic to be able to capture or express the validity that we know is there, that we see and intuit is clearly, right, that these are valid arguments. How do we formally capture or express that? We need a new logic beyond sentential logic. Because look, try and capture the validity of this with sentential logic. How do we translate all Australians as surfers? It's not a sentence combined with any truth functional sentential operator, right? So this, all Australians are surfers, just gets a single capital letter. Let's call it A, right? This is the symbolization of that in sentential logic. Just call it A. Okay, Dan is Australian. That's a simple sentence. It's not identical to the simple sentence in the first premise, the simple sentence, which is the second premise. So that gets another letter, D. Dan is Australian. Okay. Dan is a surfer. Once again, this is a simple sentence. Is it identical to either this simple sentence or this simple sentence? No, it is not. So it gets another a different single capital letter. So two premises, A and D, therefore S. It is clear that this is not a valid argument form, right? So the argument form, as per the notion of form that we use in sentential logic, right, does not capture or express the validity of this argument, right? I mean, the form of this is, of course, P, Q, therefore R, where P, Q, and R are sentential variables for taking as substitution instances any sentences. And that's clearly not a valid argument form, right? There are plenty of sentences where you could substitute something for P, something for Q, and of course R, you can substitute anything you want. Plenty of times P and Q are going to be true and R is going to be false, right? So there are plenty of counterexamples to this argument form, therefore it is not valid. There are plenty of substitution instances for this argument form where the premises are true and conclusion false. And as per the resources of sentential logic, this is the argument form of this argument, right? So it's all about the whole point of this first part is this disconnect, right? You're intuiting, you're looking at this, you're considering validity, you're clearly with certainty intuiting it is a valid argument. Same for the two arguments on page 201 with which Klenk introduced the chapter. We clearly intuit the validity of the argument. We attempt to grasp or capture the validity with the resources of sentential logic, and we fail with the resources of sentential logic. Right? It is not valid by our grasp of that form. All right. We'll end part 1 of Unit 10.